Greetings and welcome to TALE Module 2 Unit 5. We were looking at in the earlier unit the various sub processes of analysis phase. That is, we were looking at the design of a course in the framework of ADDIE, and in the framework of ADDIE the first phase is analysis, and in analysis the sub processes that we follow, they can be made specific to your requirements, and our requirement is to design a course which is offered over a semester as a part of a 4-year engineering program. And among the various sub processes we looked at in the analysis phase: course context and overview, what is its role and how it should be written, and writing the course outcomes, which we have addressed in the module 1 extensively, and then also drawing a kind of a what we call as a concept map. These are the 3 activities that we looked at. It addresses nature and role of the sub process of analysis phase. Once again, in continuation of unit 4, the remaining sub processes, these sub processes are creating sample assessment items for each one of the COs. We will presently elaborate on that, and locating the course outcomes in the taxonomy table, preparing the course PSO strength matrix. Strength matrix will actually be a row of the course, and elaborating each CO into competencies. These are the 4 processes, sub processes of analysis phase that we will address in the present unit. The writing good course outcomes is the first key element in designing and conducting a course. But this itself cannot be done in a serial fashion. You have to iteratively do this, and writing COs is done better through collaboration and should be done through multiple iterations that we have already mentioned. And we are also concerned with to compute to what extent the COs have been attained. And attainment of COs is measured through assessment that is mostly in complete alignment with the CO. We have defined what is meant by alignment with an outcome, and in the framework or context of taxonomy table, the assessment and the CO should be in the same cell of the taxonomy table. Or in another way, alignment means the assessment items are at the same cognitive level as represented by the action verb of the CO statement. That is what we call alignment. Now, writing sample assessment items in alignment with COs can lead to the improvement of CO statements. Now, what we mean by that is this: you first write COs, it may look all right, but then start. I am required to really conduct some assessment, to do some assessment to find out whether the CO is attained or not. How do we do that? That means the student should be able to perform some activity as at the end of learning that particular CO, and they should be able to solve, let us say in a simple language, they should be able to solve a set of problems at the end of instruction of that particular CO. So, what kind of problem should he solve? Those are the sample assessment items or sample problems that I need to create, and once I create those sample problems, I can look back at the CO, say are they really in true alignment with each other, and in that process I can iterate. For example, if my problems do not somehow is not exactly representing the CO, I may be required to reword the CO, or I may have to redesign some additional sample problems to really capture the CO that I have in mind. Now let us look at an example. In the course on data structures, one CO is written as write programs using linear data structures including stack, queues and linked list, which is an acceptable CO and fairly clear. Write programs would mean it belongs to apply activity, and the items that are fully in alignment with the CO, the items should actually ask the student to perform some activity or write programs or do something related to these three data structures. And here the sample test items are given like this: perform insertion of 100 and deletion of 87 from the linked list given, which is listed there. And second one, insert data, those items into the linked list and perform linked list reversal. Write a program to insert 100 in a given one dimensional array at the fourth location in the list. List is given. And the fourth problem was write a program to eliminate all duplicates from the given array. Now if you look at let us look at some comments on this. All sample problems that we have chosen appear to be linked list or arrays. The other stack and queue are not addressed in the sample problems. So when I give sample problems to the students, they will feel that the entire CO is only constrained to linked list and arrays. So what happens, I need to either alter the CO, say that remove from the CO the other two stack and queue from the list, or my sample problem should include problems related to stacks and queues. So examples from stacks and queues are required. As we said, sometimes based on the problems, now I am looking at some problems, exactly the kind of problems that I would ask the students to solve. From that, either I reword my CO statement, or I will modify my sample set of problems. Okay, here in this case we find that there is no need to change the CO statement, but now I write a set of problems that represent all the three data structures that were mentioned in the CO statement. So you have now problems like write a program to evaluate the given expression using a stack, and implement a circular queue of size n using an array of size n and auxiliary variables as necessary. So we removed two problems or replaced two problems with the problem related to stack and queue. Once again, please remember these are only sample set of problems. And why are they required? Actually, along with the sample problem, you should also include this sample answer. By looking at the sample answer, the kind of work that is required, the kind of prerequisite knowledge that is required can be ascertained, and that kind of thing will help the teacher in planning the instruction. So writing a good set of sample test items is a prerequisite before we move on to actual instruction. So this is one of the sub process in the analysis phase. Now we look at locating the COs in taxonomy table. Now these are COs of a course on analog circuits and systems. It is written as 3:0:1. It can also be 4:0:1 depending on how the teacher wants it. And the course outcomes are written, I will just read one or two. For example, CO3 understand the behavior of simple signal processing applications of passive and active electronic devices. When you look at it, you can tag it with the cognitive level, that is understand U, and it uses both conceptual and procedural knowledge. How something is performed, I need to understand that. Okay. So, it is tagged as U dash C comma P. And if you look at another one, CO4, understand how negative and positive feedback can be used to perform a wide range of signal processing and conversion operations precisely using devices that have parameters sensitive to temperature, voltage and time. And here we now tag it with, it is still understand, there are concepts, and we put FDP, that is fundamental design principles, the very use of negative and positive feedback to influence the performance of a electronic circuit is a fundamental design principle, and that the students need to understand. So, we have tagged it with FDP. Similarly, the other COs of the same course, we have created as 9 of them, they are all tagged correspondingly. Okay. Let me read something. CO6 is a major topic of filters, design passive and active biquad analog filters in the baseband region as per given specifications. Here we have explained earlier, though we use the word design, it actually belongs to application. That means the actual design of passive filter or active filter should follow a well defined process that is already communicated. And the knowledge categories include conceptual, procedural, and C and S is criteria and specifications. So we are tagging now with both the cognitive levels as well as knowledge categories, all the COs. Now these can be located inside a taxonomy table. So we have shown this earlier in the module 1 as well. So all the cognitive levels are shown on as rows, that is remember, understanding, apply and so on, and on this we are showing the all the knowledge categories. And as you can see, depending on the tagging that we have done, we located each CO in that. Now take for example CO2. CO2 is part of conceptual as well as procedural, because both the things are involved in that. So CO2 will appear in 2 different cells. And if you look at CO1 for example, it will appear in 3 cells, right from factual knowledge, criteria and specifications, and practical constraints. It will appear in all of them. And if you look at CO5, CO6, CO7, they will appear in the conceptual, apply, and apply procedural, and apply criteria and specifications. By looking at this, one may feel that either if there is any particular cell that you want to address and you do not find in this, then it is a feedback to the course designer that it may be required to reword or take a review of your course outcomes. So this is a process of iteration. So one of the tools that we use is the locating COs in the taxonomy table. And when we are designing assessments or when we are designing instruction, that also we need to locate in the corresponding cell. So the taxonomy table really presents you as a kind of it's an artifact that allows you to look at the alignment between various activities, or whether we are addressing all the relevant knowledge categories or not. And for example, here we are not addressing the metacognitive part. It does not mean that metacognitive knowledge category is unimportant. Possibly we may or may not have the required knowledge and tools available to address that particular issue. But any decision that you make, it should be conscious, and why we are not addressing the, let us say, the column of metacognitive. So that is the purpose of taxonomy table. Now we move on to something that we have already seen, that we are addressing. We have already stated that the program is characterized by program outcomes and program specific outcomes, and these POs and PSOs are mainly addressed or attained through core courses. And though there are, besides core courses, you may have projects and some co-curricular and extracurricular activities, but dominantly POs and PSOs need to be attained through formal courses, core courses. So what happens, as we need to compute or find out to what extent POs and PSOs are attained, there are two issues. One is because we are tagging our COs with POs and PSOs, that we have seen. But to what, just because I merely address that, I consider PO is addressed, do I call it whatever, if I briefly somehow mention that aspect in my class, do I consider that it is adequately addressed? So what happens, we bring in the concept of the strength to which a particular PO is mapped to a CO. This we have looked extensively in module 1. So attainment of a PO or PSO depends both on the attainment levels of associated COs of core courses and the strengths to which it is mapped. And each course outcome addresses a subset of POs and PSOs to varying levels. So any course you take, it will only address a subset of POs and PSOs, and the strength is put as 1, 2 or 3, or you can say slightly, moderately and significantly, whatever wording that you want to use, you identify 3 levels. You can put more levels, but then it becomes more difficult to kind of keep track of that. And we have to find a way of, from once I give the course description through COs, and then I tag them with POs, PSOs, cognitive levels, knowledge categories and the number of sessions. Now I have to somehow, that is the only information that I have. From this I need to determine the mapping strength of a particular PO or PSO. And as we said, strength of mapping is defined at 3 levels: low is 1, medium 2, strong is 3, or you can call it slightly, moderately and significantly. So how do we do this? We have given a methodology in the module 1, and we are just I am representing that. This is one simple method. If one wants, you can redesign that method. For example, if more than 40% of classroom sessions or lab hours addressing a particular PO, it is considered that PO is addressed at level 3. For example, I may differ with that. I say unless it is greater than 60%, I do not consider it as level 3. Yes, the faculty of a particular institute should sit together and decide these percentages. If you do not want to follow this method at all, you can follow some other method. You are welcome to that, but it should be justifiable and can be used with respect to all the courses. So here the strength of mapping, we are defining it only in terms of number of classroom sessions that we are taking, and we have defined the level. Actually 0 is also there, less than 5% of the classroom sessions are used for addressing a particular PO, then we consider it is not addressed at all, or that level is 0. So, you have 1, 2, 3 levels defined like this, and this is captured like this. There are 12 POs and there can be 4 PSOs. It is 2 to 4 PSOs. Then what do? We are taking a hypothetical course and say based on classroom sessions taken for each CO and the tagging that we have used, we came up with these numbers. That means PO1 is addressed to the strength of 1, and PO2 is addressed to strength of 1, and PO3 to the strength of 3. PO5 is addressed to the strength of 2, and PO10 1 and PSO1 3. One may disagree with that, but then you have to reword your course outcomes to modify these numbers. And it is very clear this particular course is not addressing PO4, PO6, PO7, PO8, PO9 and PO11 and PO12 as well, and PSO2, 3, 4 are also not addressed. Generally this is the way a course would look. That means you may have anywhere from 2 to 5 POs addressed to varying strengths, and possibly if your PSOs are written right, a course will address only one PSO. Depending on how you write, it may address maybe additional PSOs. So, this is one of the steps that one needs to do, because this information we are going to carry forward to the later phases of course design, that is subsequent phases, namely implement and evaluate. Now, let us look at another issue, another process in analysis phase. What happens is, if you look at CO5, which we have given the example, design circuits that perform analog linear signal processing functions including amplification, summing, differentiation and integration, and nonlinear signal processing functions including log, anti-log amplification, current sensing, rectification and DC voltage regulation. That is a CO written somewhat elaborately, because one can add or delete some of the items in this. For example, a teacher may decide that I do not want to look at log and anti-log amplification because of the lack of time, or I consider at the first level at this level of this course I do not need to address that. So, it was found that we will require about 11 classroom sessions. If it is so, that means 11 classroom sessions have to be planned. I have to partition the material, I have to do some sequencing, and I have to keep intervening or introducing student based activities to facilitate students to get engaged with the knowledge of this, and so on. Planning 11 sessions as one call it package or one unit can be tough. So, what we do is we will break it into as you can see from the very statement of CO5, I can break it into multiple what you may call outcomes, but a next level outcomes I need to give a name to that. So, we call it officially competencies. Strictly speaking, outcome and competency mean the same, but for our convenience we say CO5 C1 competency 1, CO5 competency 2. So, we broke it into 4 different competencies under the same. We are not going to address anything new in this, but we reword that. Now, what happens, the first unit of the CO5 becomes design amplifiers, which we list what we call VCVS, CCVS and so on, starting with ideal op amps and using state of the art commercially available components, and it was felt that 4 classroom sessions are required to perform this activity or to instruct in this activity, which will also include the students doing students getting engaged with that. That will come as a part of instruction. Now, it is much more convenient to kind of plan activities with smaller units like this. Here we divided the first competency, it requires 4 classroom sessions, second one 4 classroom sessions, third one only 1, and fourth one requires 2. So, by writing this, it also kind of acts as a kind of feedback once again to the course designers, that after breaking into these competencies, I may want to go back and reconsider my what do you call the course outcome statement. I may want to reconsider that. So, what happens, the entire thing is there are several iterations within each phase, so that finally we come with the correct set of what we call proper set of course outcomes for this. So, what is the key output of analysis phase? As far as engineering courses, courses in formal engineering programs are concerned, the primary output, the most significant output is a set of course outcome statements and elaborating these course outcome statements into competencies. That is the formal output of the analysis phase, and these are in turn you have it kind of get reviewed by peers, because when somebody outside kind of looks at it, he may point out some missing things, or that your estimates maybe they may express opinion. It will be very valuable inputs if you get it peer reviewed and consider whether any changes that you want to make. That is what we call formal evaluation of your analysis phase outputs. That is what finally you produce from analysis phase. And here we suggest this exercise, they can be quite elaborate. Describe any different sub-process you consider necessary to include in the analysis phase of ADDIE with respect to designing your course. Because we have given you 4 plus 3, 7 sub-processes in analysis phase. And in your view you think, because this set is not unique, so the set can be made smaller or bigger based on your perception of the course. Let us say each one of you have your own experiences with your own courses. Based on that, you may suggest either additional process or simplification of the sub processes as presented here. And we will also suggest that you perform all the sub process of analysis phase with respect to the course you taught or familiar with. And if you can share your output with us, it will become a very good source based on which we can interact with you more. And in the next unit, actually we should call it M2U5. We try to understand the sub process of design phase, and thank you very much for your attention.